Okay, so now we're going to take the second derivative, and I've got an example for you here. And we're going to find dy over dx and the second derivative of dy over dx and determine when the curve is concave up. And our function of x is t squared plus 5 and of y is t squared plus t. So if you remember in the previous video, the first derivative, so dy over dx, is equal to dy over t dt divided by dx over dt. And you can think of this as canceling the dt's in the bottom to leave you with dy over dx. And now the second derivative, we need to first have the first derivative here. So with the second derivative, we take the derivative with respect to time of the first derivative, and then divide that by dx over dt. So first, let's take dy over dx. So dy over dx is equal to, well, dy over dt is going to be 2t plus 1. And dx over dt, so the derivative of x with respect to t, is simply going to be 2t. And you can see now that we can simplify this a bit, so we could also write it as 2t over 2t plus 1 over 2t, and this will just go to 1. So this is equal to 1 plus 1 over 2t. And now we have our first derivative, so now we can get our second derivative. So the second derivative of x, or of y with respect to x, is going to be equal to the derivative with respect to t for dy over dx divided by dx over dt. So this is equal to d over dt times our derivative we just worked out, so 1 plus 1 over 2t, and dx over dt we already figured out as 2t on the bottom here. And so you can see that, so if you have 1 over t, the derivative of that is going to be 1 over t squared. So in this case, it's the same example, or negative 1 over, because we've got, you could write this is the same as t to the negative 1. So the derivative of 1 plus 1 over 2t is going to be 1 negative 1 over 2t squared divided by dx over dt still, so 2t. And then I always like to simplify it a little further, so you can multiply these terms here, and I always think of just flipping it up, so I'll multiply these two terms here. So this is going to be equal to negative 1 over 4t cubed. And now, so this is our second derivative of y with respect to x. So now we just need to figure out when it is, so when it is concave up. And you can see that this will be concave up when the second derivative is greater than 0. So that's going to happen when t is less than 0. And that's because if t is less than 0, then we're going to get a negative on the denominator here. And those two negatives will cancel, making it positive. So that is it, and I will see you in the next example.